Welcome back. Last week we discussed about some of the important trigonometric identities, and today let us revise all those ones and we'll go to the next problems. Now cos of x plus y is cos x cos y minus sin x sin y, and if it is minus it becomes positive. So don't write both together. So depending on the sign, this if it is plus here you get minus, and cos x minus y will be cos x cos y plus sin x sin y. Similarly, we discussed about sin of x plus y. It is sin x cos y plus cos x sin y. If minus is there, the sign is also here minus. Similarly, tan x plus y. Tan x plus tan y divided by 1 minus tan x tan y. Instead of plus, if we have minus, it becomes tan x minus tan y divided by 1 plus tan x tan y. And cot x plus or minus y. Again it is cot x cot y minus 1 in the case of plus. So here it is minus and denominator will be plus. Similarly, if you have cot x minus y, here you get plus and here you get minus. Now the important one is cos 2x. Cos 2x can be written in different forms. That is, in terms of cos and sin, we write it as cos square x minus sin square x. In terms of cos, it is 2 cos square x minus 1. Similarly, in terms of sin, it is minus tan y divided by
एग्जाम ಬರ್ತಿದ್ದಲ್ಲ
in terms of tan, it is 1 minus tan square x by 1 plus tan square x. Now, in this case, understand this. Suppose if I write cos x, cos 2x is this value. Now, cos x can be written by dividing by 2. So, we call it as half angles. We are dividing the angle by 2. So, in that case, it becomes 2 cos square x by 2. It is divided by 2 here. Here also we divide the angle, and sin square x by 2. This is also one of the important forms what we have. Similarly, this one can be written as 2 cos square x by 2 minus 1. So angles will be divided by 2. 1 minus 2 sin square x by 2. Getting it? Similarly, this can be written 1 minus tan square x by 2 by 1 plus tan square x by 2. So this we apply whenever we have cos x. So cos 2x formula is this. From this we can get cos x in this form. Similarly, sin 2x is 2 sin x cos x. Now it can be written in terms of tan as 2 tan x divided by 1 plus tan square x. Now can we write the sin x in the form of this half angles? Definitely it can be written. So we say sin x can also be written as 2 sin x by 2 into cos x by 2. Very important one. And similarly here is 2 tan x by 2 plus 1 plus tan square x by 2. So wherever you have this, we can get half angles by dividing the angle by 2. Similarly here, tan 2x is 2 tan x divided by 1 minus tan square x. You should remember this formula. Similarly, sin 3x is 3 sin x minus 4 sin cube x. Cos 3x is this. Similarly, tan 3x is 3 tan x minus tan cube x by 1 minus 3 tan square x. See, to solve the problem, children, you should be perfect in all these formulas. Okay? So now, other day I have given some homework. Let us discuss that. Then I will go to the next type of problems. I think I gave a homework. It was cot square pi by 6 plus cosecant 5 pi by 6 is cot pi by 6 whole square cosecant. Now 5 pi by 6, you can write it as pi minus pi by 6, isn't it? Right? If you take LCM, it becomes 6 pi minus pi, 5 pi divided by 6 plus 3 tan pi by 6 whole square. So what we need to prove? This is 6. So now cot pi by 6, it is what? Root 3, isn't it? 30 degree, cot 30 degree is root 3 whole square plus, now pi minus theta, that is 180 minus theta, lies in the second quadrant and we find that cosecant is positive. So this we get here cosecant pi by 6 plus 3 times 1 by root 3 whole square. Okay, so what is it now? This is 3 and cos pi by 6 is cosecant pi by 6. Sin pi by 6 is how much? It's half. So its reciprocal means we get it as 2 and here root 3 square, that is 3. 3 plus 3, 3 by 3, so it is 1 and we get the answer as 6. Okay, so write down this. Check your answer, this was homework. Okay, next one. Write this. 2 sin square 3 pi by 4 plus 2 cos square pi by 4 plus 2 secant square pi by 3. We have to do that, it is equal to 10. Okay. So this is 2 sin. Now 3 pi by 4 can be written as pi minus pi by 4. It's square. Getting it? When you take LCM, 4 minus pi. So it is 3 pi by 4 plus 2 cos pi by 4 whole square plus 2 secant pi by 3 whole square. Clear? Now, this is 2 sin 180 minus theta, that is in the second quadrant and it is sin theta itself. Sin pi by 4, look at this, sin pi by 4 whole square plus 2 cos pi by 4 whole square plus 2, this is same, secant pi by 3 whole square. Now just you need to substitute all the values. This 2 into 1 by root 2 whole square plus 2 into 1 by root 2 whole square. So cancel this. 2 square is 1 plus 1 and what about this? 2 times secant pi by 3. Secant is a reciprocal of cos. Cos pi by 3, cos 60, half square. So it is 4, 2 into 4. So this is 8 and the right hand side is 10. Is that clear? What we did see here? 3 pi by 4 is nothing but sin pi by 4. The reason is it can be written as 180 minus 45 degree. So pi minus pi by 4, it lies in the second quadrant. Sin is positive and it is sin pi by 4. Its square is there. Sin pi by 4 is 1 by root 2 and its square it is half. It cancels with this. So we are left with 1. Similarly here it is 1 and in this case it is secant pi by 3 whole square. It is 2. 2 square is 4. 4 into 2, 8. So totally final answer we get it as 10. Right. Next one, find the value of sin 75 degree. find the value of sine 75. Now in such problems are given, this is important. Sine 75 is there. So we can go for sine x plus y formula or sine x minus y. So here which formula we are going to use? Sine 75 we need. So I can write it as sine 30 plus 45, isn't it? Sine 30 degree plus 45 degree, which is in the form of sine of x plus y. What is the formula? Sin x cos y plus cos x sin y. We'll substitute now. Sin 30 into cos 45 plus cos 30 into sin 45 degree. Substitute and get the answer. Sin 30 is 1 by 2. Cos 45 is 1 by root 2 plus cos 30 is root 3 by 2. This is 1 by root 2. Okay, now we can take LCM. It is 2 root 2 and 1 plus root 2 in the numerator. So sin 75 is 1 plus root 3 divided by 2 root 2. Right, this. Now let us try the other one. Same type, sin 15 degree. So how to get sin 15 degree? Same form. So try that. Go for 60 minus 45 degree. Same way. Everything is same. Here it is sin 60. Cos 60. Try this. And here the sign is minus. Okay. So sin 60 is root 3 over 2. 1 over root 2 cos 45 minus cos 60 is half. Sin 45 is 1 by root 2. Again we will take LCM. It is 2 root 2 root 3 minus 1. Clear? Now this can be further simplified. Root 3 minus 1 by 2 root 2. So let it be. So sin 15 value is this. Root 3 minus 1 divided by 2 root 2. Now same type can be applied even for cos, tan and all, because we know the formulas of all this. So now can we get tan 15 from this? Check it. Tan 15 degree. How to get it? It is tan 60 minus 45. Tan 15 we made. So it is 60 minus 45. So what is the formula we have? Tan of x minus y is tan x minus tan y by 1 plus tan x tan y. We can try this. Tan 60 minus tan 45 by 1 plus tan 60 into tan 45. Substitute and get the answer. 2 minus root 3. You can verify this. 2 minus root 3 will be the answer. The next one. Write down. Prove the following. Cos pi by 4 minus x. Cos pi by 4 minus y minus sin pi by 4 minus x into sin pi by 4 minus y. This you have to prove it as sin of x plus y. So very simple one. Left hand side is this. You are going to prove that it is equal to sin of x plus y. See, when you get such problems written, first you have to see it is in which type of standard forms. Here it is cos x cos y minus sin x sin y. Getting it? See, cos x, if you consider pi by 4 minus x as x, and this you take it as y. So cos x cos y minus sin x sin y. Correct? Now this formula is what? Is cos of x plus y. Right? So we'll substitute now. Cos of x is pi by 4 minus x. Cos x plus y. Plus pi by 4 minus y. So the whole left hand side is nothing but this. Can you get? It is cos x cos y minus sin x sin y. In that standard form it is given, and we know that this is cos of x plus y. Is that clear? Now cos of x plus y, x, this is x and this is y. Cos of x plus y. Now add these two. It is cos pi by 4 plus pi by 4 is pi by 2 minus, we'll write it as x plus y. Clear? Now 90 minus theta, it is sin theta. Theta is x plus y. 90 minus lies in the first quadrant. Cos is positive. So this is the answer. Right hand side we need sin x plus y. So that's what we are going to get if we apply this result. Write down this. Next one, prove that tan pi by 4 plus x by tan pi by 4 minus x equal to 1 plus tan x by 1 minus tan x whole square. This is also important. Tan pi by 4 plus x divided by tan pi by 4 minus x. So we need the right hand side in this form. Now the first one is of tan x plus y form, and this is tan x minus y. So straight away we are going to apply the formula of tan of x plus y. So what is that? It is tan pi by 4 tan x plus tan y. So x is pi by 4, y is x. So tan pi by 4 plus tan x by 1 minus tan pi by 4 into tan x. Correct? This is the numerator. Now whole divided by. Now apply the standard result of this. It is tan pi by 4 minus tan x divided by 1 plus tan pi by 4 into tan x. Okay? Now what about this? See, we know that tan 45 degree is 1. So tan pi by 4 is 1 plus tan x. We are getting tan pi by 4. I am writing it as 1 by 1 minus tan x. Correct now? Tan pi by 4 is 1. 1 into tan x. This divided by, here also 1 minus tan x divided by 1 plus tan x. See, we are going to get the answer directly. So when you take it to the numerator, you get 1 plus tan x divided by 1 minus tan x whole square. Okay, this is the right hand side. Right this. Next one. x into cos minus x by sin pi minus x cos pi by 2 plus x. So this we have to prove that cot square x. This is again simple. Cot 180 plus theta. See, first you say in which quadrant it lies. Now cos 180 plus x, that is it lies in the third quadrant. Cos is negative and it becomes minus cos x. And cos of minus x in the fourth quadrant becomes cos is positive. It can be written as cos x divided by here 180 pi minus x means it comes in the second quadrant sin pi minus x. So this is on the x-axis, sin is sin, so it is sin x. In the second quadrant sin is positive. Now pi by 2 plus x, again 90 plus theta comes in the second quadrant, it is cos pi by 2, it is an odd multiple of pi by 2, so ratio changes to sin x. Okay, now the sign in the second quadrant, it is negative. Clear? So we have minus cos square x divided by, now we know that minus sin x, it is you take it to the other side, this side, it is minus sin square x. Negative sign cancels, we have cot square x. Okay, right. Next one, this problem is important. Cos 3 pi by 2 plus x into cos 2 pi plus x into cot 3 pi by 2 minus x plus cot 2 pi plus x. This you are going to prove that it's equal to 1. So important one. Even though the expression is big, the answer is very simple. What you need to do is you see these values, angles lies in which quadrant, and accordingly you change put the sign. Now if you look at the first one here, cos 3 pi by 2 plus x. Now 3 pi by 2 means 270 plus theta in the fourth quadrant. Cos is positive. So here 3 pi by 2, cos ratio changes to sin. So we have sin x. Clear? Getting the answer? 3 pi by 2 plus x. So fourth quadrant, cos is positive, so positive sign, and it is 3 pi by 2, odd multiple of pi by 2 means cos changes to sin. So it is directly we write it as sin x. Similarly, cos 2 pi plus x. 2 pi is 360 degree plus x means the second revolution starts. So it is first quadrant, and 2 pi, so this won't change and it remains cos x. Okay. In the first quadrant, cos is positive. We'll come to this one. Cot 3 pi by 2 minus x means it comes in the third quadrant, and we know that it is positive. Cot is positive over there. So this becomes tan x. Clear? Why it is tan x? Multiple of 3 pi by 2. That is odd multiple of pi by 2. Cot changes to tan. Now cot 2 pi plus x, again in the first quadrant, and it is a multiple of pi, ratio doesn't change, cot will remain cot. Sin is positive. Now we'll simplify this. Sin x into cos x. Now tan you write it as sin x by cos x. See why we are substituting? Because we have to prove that it is equal to 1. So cot I write it as cos x divided by sin x. Now Now next we'll take LCM. This is sin x into cos x. When I take LCM, it becomes cos x into sin x. Right? When you multiply by this, it becomes sin square x, and here you get cos square x. You can cancel this. It cancels. So we have this sin square x plus cos square x, which is 1. Is that clear, children? Just you need to simplify by saying in which quadrant it comes. 3 pi by 2 plus x. So you have to think it is odd multiple. 3 pi by 2 plus x means in the fourth quadrant, and then cos is positive. So directly we get it as sin x. Similarly, 2 pi plus x, it is first quadrant and ratio doesn't change. It will remain as cos x. In this case, 3 pi by 2x minus x. In the third quadrant, cot changes to tan and it is positive. Similarly, in the fourth case, cot 2 pi plus x. In the first quadrant, cot is positive. It is cot only because it is a multiple of pi. So after substituting, what we did? Taking tan as sin by cos and cot as cos by sin. Taking LCM and simplifying, we get the answer 1. Okay, write this. Write this sin n plus 1x into sin n plus 2x plus cos n plus 1x into cos n plus 2x. This you have to prove that it's equal to cos x. See, now this is in the standard form. Sin x into sin y plus cos x into cos y. Right? This standard result is cos of x minus y. Now x is this thing and this is y. So this expression directly we substitute in cos x minus y. This cos x is n plus 1 into x minus y n plus 2 into x. Clear? So it becomes, remove the bracket, is nx plus x minus nx minus 2x. Okay? Cancel these two and we get here cos of minus x. Cos minus x is cos x. This is the right hand side. Why it is like cos minus x? Minus x in the clockwise direction and it comes in the fourth quadrant. Their cos is positive. So it is cos x. Is that clear? Just take this as x and this as y. That's it. And compare it with the standard result. Since it is in the form of sin x, sin y plus cos x, cos y, we substitute all this in this formula. Cos x minus y. And x is here n plus 1x. Y is n plus 2 into x. Removing the bracket and simplifying, we get cos x. Next one. Write the when we have decided in transformation. Transformation form. Transformation means we can express the sum of the function as product of two functions, or when product is given it can be expressed as sum or difference of other two functions. So that time, that is expressing product in the form of sum or difference or sum or difference in the form of product, we call it as transformation rule. So for this, the basic things is what we discussed till now. That is, we know the formulas of cos of x plus y, cos x minus y, sin x plus y and sin x minus y. So using that concept, children, let us try to understand this transformation rule. See, now cos of x plus y, formula we know already. Suppose if I add this with cos of x minus y, what I am going to get? You are getting it? Cos x plus y and cos x minus y, when I add it, I get a product. So what product we are going to get is, say, I substitute here, cos x plus y is cos x cos y minus sin x sin y plus, let me add this now, cos of x minus y is cos x cos y plus sin x sin y. See, when we add this, these two will cancel and we get it as 2 cos x cos y. So this identity is very important. It is 2 cos x cos y. So very important one. Clear? That is, sum of these two are expressed as product of cos x cos y. On the other hand, 2 cos x cos y, if it is given, you can write it in the other form. So 2 cos x cos y is cos x plus y plus cos x minus y. So remember, when you add these two cos, you get the answer in terms of cos itself. Now if we subtract what we get, we'll say, if you want you can write on this. Let me subtract now. That is cos x plus y minus cos x minus y. Let me do. What we are going to do? We are getting, say, cos x plus y is cos x cos y minus sin x sin y minus cos x minus y is cos x cos y. This becomes plus into minus. So I remove the bracket and write together. This minus sin x sin y. Now these two will cancel. So what we get here is minus 2 sin x sin y. This is also very important one. That is 2 sin x sin y can be written as cos x plus y minus cos x minus y. That is, when we subtract cos formula, we get minus 2 sin x sin y. On the other hand, if this is given, sin x sin y is given, it can be expressed in this form. Okay. Now similarly, sin we know, sin of x plus y plus sin of x minus y will do. That is, we are adding these two, we'll see what we get. Sin x plus y is sin x cos y plus cos x sin y, right? Plus, here it is minus, it is sin x cos y minus cos x sin y, isn't it? Now cancel these two, cos x sin y and cos x sin y. We have sin x cos y plus sin x cos y is 2 times sin x cos y. Clear? So this is also one of the important results what we have. So this I write like this. So 2 sin x cos y is sin x plus y plus sin x minus y. Now if you subtract, say, sin of x plus y minus sin of x minus y, what we get, say, it is sin x cos y plus cos x sin y, okay, minus sin x cos y, and here it is minus, it becomes plus cos x cos sin y. Okay, sin x cos y and minus sin x cos y cancels, so we have 2 cos x sin y. Okay, so again this is important. Look at this. Easily we can express all these things like this, and remember you should know this by heart. Sometimes what happens when product is given, in the problem it may be required to getting the answer in the form of plus. So in that case, to simplify the answer we go for this. So whether it is given in this form or this form, you should know which form you need and accordingly you are going to put this. So remember this, when we add cos x plus y and cos x minus y, we get both in terms of cos, 2 cos x cos y. Similarly when we subtract, it is negative. See, if you compare this 4, only this is negative. So it is cos x plus y minus cos x minus y is minus 2 sin x sin y. You have to remember this. And how are you going to remember this too? Sin x plus y plus sin x minus y. It is 2 sin x cos y. So when you add it, when you add these two, sin x comes first. 2 sin x cos y. When you subtract, cos comes first. So it is 2 cos x sin y. Is that clear? So all these 4 are very important. Now suppose, understand this, from these 4, what happens if I put x plus y as, say, a? I am taking, look at this, x plus y if I put it as a, and the difference I put it as b. X plus y, I am taking it as a, and x minus y as b. And when I add these two, what I get? X plus y plus x minus y. Y cancels, I get 2x equal to a plus b, isn't it? So what is x now? A plus b divided by 2. Okay. Similarly, if I subtract this, I get 2y is equal to, you can check it, I am subtracting, I get a minus b. So y is equal to a minus b by 2. So now, wherever you have that values, we are going to change it in this form. That is, just look at this. See the first one. I put x plus y as a now. So what I get on the left hand side? Cos a plus cos b. Is that clear? X minus y, I am going to take it as b. This is a and that is b. Cos a plus cos b becomes 2 cos. What is x children? X is a plus b by 2. So a plus b divided by 2 into cos y. Y is a minus b by 2. Very important one. So whenever it is given in this form, cos a plus cos b, every time don't expect this. Instead of that, it will be given in terms of cos a plus cos b, and it is the sum. It is expressed as product of the half angle, sum of the and difference of these two. That is a plus b by 2 into cos a minus b by 2, which is important. Similarly, cos a minus cos b, when we subtract it, is minus 2 sin x sin y, isn't it? So x is nothing but a plus b by 2. A plus b divided by 2 into cos a minus b divided by 2. Okay. So what about sin a plus sin b? We know that it is 2 sin x cos y. So it becomes 2 sin sum of the half of the sum of the two angles, a plus b by 2 into cos a minus b by 2. Clear? And here, just wait, this is sin. This is sin, in this we are substituting, and here we are going to substitute 2 sin x as 2 sin a plus b by 2 into cos a minus b by 2. Similarly, the last one, sin a minus sin b. Getting it? Substitute here. It is 2 cos a plus b by 2 into sin a minus b by 2. So children, you should remember all these formulas, all, each and every one. You should know what is cos a plus cos b, or also what is 2 cos x cos y. Now instead of a and b, you can take it as cos x plus cos y also. When you take it cos x plus cos y, you get it as 2 cos x plus y by 2 into cos x minus y by 2, and accordingly the remaining 3. So please by heart this, and using this formulas will solve some problems. Next one, right? Prove that cos of 3 pi by 4 plus x minus cos 3 pi by 4 minus x. This is equal to minus root 2 sin x. You getting it? Cos pi by 4 plus x minus cos 3 pi by 4 minus x. See, if you observe it, it is in the form cos a minus cos b, right? So cos a minus cos b, when we subtract it, we get minus 2 sin a sin b. So let me write that first. It is cos, in general let me write cos x minus cos y. We are subtracting this. It is minus 2 sin x plus y by 2 into sin x minus y by 2. This is the formula. Now, x is 3 pi by 4 plus x and y is 3 pi by 4 minus x. So, in this, we are going to substitute these values. This minus 2 sin, look at this, 3 pi by 4 plus x plus 3 pi by 4 minus x by 2, clear, into sin 3 pi by 4 plus x minus 3 pi by 4 minus into minus is plus by 2. Okay. Now simplify. This is minus 2 sin. Look at this. These two cancels. It is 2 times 3 pi by 4 and by 2, this 2, into sin. These two cancel, is 2x divided by 2. Okay. Now you can cancel these two. So what is remaining here is minus 2 sin 3 pi by 4, and these two you can cancel, into sin x. Okay. Now this is minus 2 sin 3 pi by 4. How do you write this? Sin pi minus pi by 4. 180 minus theta into sin x. So this is minus 2 sin pi by 4. Is that clear? 180 minus theta in the second quadrant, sin is positive, into sin x. So this becomes minus 2 into 1 by root 2 sin x. Now, but what we have to prove, right hand side is given as minus root 2 sin x. So for this, take 2 as root 2 into root 2. Getting 2, write it as root 2 into root 2, and here divided by 1 root 2, 1 by root 2 into sin x. So these two cancels and we get the right answer as minus root 2 sin x. Is that clear? So this is the right answer. Just go through this once and remaining problem we are going to discuss in the tomorrow's class. Thank you, children.